Okay, next part we will talk about part 4, the measurement method. Actually, in this part, we will talk about the MSA and the sigma matrix and the yield calculation. First, we talk about the measurement system analysis, aka MSA. Typically, we found some data through the measurement, and in Six Sigma, we make decisions based on the data analysis. So, the measurement is very, very important. Okay, just like the key of building a AI system, the data quality is also very important foundations. So our problem is the major value, the major data is accuracy or not. Okay, so how significant if the error in your system is how significant? Okay, so let's talk about the measurement, major system analysis, MSA. So, in major phase of EMAIC in Sigma, we got to make sure the measurement system can accurately access the output, the Y. So, as we know, the total observed variation equal to have two parts. Okay, the first part is the variation truly come from the process. The second part, the variation come from the major system. So we hope the most of variation is from the process. Okay, we don't want the variation from the measurement system is too big. Okay, so we got to understand what is the potential factor can affect the measurement quality, something like personnel, instrument, equipment, tools, and the procedure. Uh, Actually, let us introduce the source of variation. Okay, actually, total variation from the can be divided into process in the inherent variation and in inherent variation. This variation from the product, as we know, product by product. Okay, and the second part is from the measurement. Okay, and in measurement, it can be divided the other two variation. The subgroup is called repeatability and reproducibility. Okay, so in this part, we got to know, you know, uh, we got to know our variance. We got to measures, majorly come from the major variance and the past variance. Past variance, it come from the process. Okay. So past variance initially PV represents the variance between the parts to parts, and over time in a stable process. And let me explain accuracy and the precision. Accuracy is to measure is the degree how close to the true value. Okay, or how close to an acceptable reference value. Okay, the precision is mean the degree of the closeness between each repeat reading. That mean if maybe we will measure more than one times. So in first time and the second times, the reads how close between these measurements. Okay, next let's introduce the MSA. So in MSA, is to evaluate some characteristics of the repeatability, reproducibility, BIOS, stability, and linearity. Okay, so uh, uh, the study of the repeatability and the reproducibility, aka gauge R&R study, that address the variability of the whole measurement system, and the study of BIOS, stability, linearity, let's address the accuracy of the measurement system. So in this part, we focus on the gauge R&R. So the whole terminology come from, some automobile, group, the three very big car company. I mean, in the past, okay. So it's come from the AIAG reference menu. Okay, so let me explain how many errors come from the measurement system. Actually, measurement systems errors can have some variations, caused by the combinations of BIOS, repeatability, reproducibility, stability, and linearity. Okay, first let's introduce the BIOS. BIOS means the difference between the average value, average, no matter how many times you try to measure, so you got the average value. So how the difference between the reference value and the average value, that's mean BIOS. Okay, we provide example. If you want, you can follow, and you can find how to calculate the BIOS. Next, we talk about the stability. Stability means the change in BIOS over time, aka dropped. So from day after day over time, some BIOS may be dropped. Okay, maybe dropped. So stability means the consistency of the measurements of time. Okay. That's another example. You can, if you want, you can follow it and do it. We will skip very quickly. Okay. Next, we talk about linearity. Linearity is the variations in BIOS. Okay, the variation in BIOS. So till now, we talk about the BIOS, we talk about the stability, we talk about the linearity. That's to measure the accuracy of the measurement system. That's another example of calculation the calculation of the linearity. So if you want, you can try. Okay. Another example. Okay. Next, we talk about the repeatability. Repeatability, as we know, is called equipment variations. and we want to know if the same guys use the same tools to measure the same parts. Any possibility, any variation, the results will not consistent each time. Okay, so uh, repeatability is the variation come from repeat measurement. Okay. So in practice, repeatability. That means the variation from the equipment, major equipment. Okay. Okay. Next, the second one is the reproducibility. Reproducibility is uh, uh, different operator using the same tool to achieve the consistent results. So we can understand the reproducibility. That means the variation come from operator, come from appraiser, okay, appraiser, okay, the guys who measure uh, the object. So reproducibility, that means the variation come from the people. Okay, let's uh, the you know the relation between the repeatability and the reproducibility. So we can know, yeah, repeatability is variation from the tools, and the reproducibility, the variation from different operator, different appraiser. According to definition of Minitab in 2K2, EV, aka repeatability, is mean the variation due to the major device. AV, aka reproducibility, is the variation due to the major system. So, the purpose of measurement systems is to understand the source of variation that can influence the results produced by the major system. So we can remove the source of variation come from the major systems. So typically is a approach from the two perspective. The first one is locations. The second one is spread. Okay, so if we want to know accuracy, so location, so we got to check the BIOS stability and the linearity. Okay, if we got to focus on the spread, that's mean the variations, repeatability. That mean the error from the uh, equipment, repeatability, the error from the operator. So in industry, gauge INA analysis is common used to address to evaluate the measurement system. Okay, let's talk about gauge INA. Gauge INA is used to determine if the variance of the gauge, the major tools, the major equipment is small enough. Okay, so compared to the tolerance or compared to the part variation.